Good morning, students. This is your third class of motion chapter. In the previous two classes, we have studied introduction of the motion and rest definitions, types of motion, scalar and vector quantities, distance and displacement, their definitions, numericals based on distance and displacement, relation between distance and displacement. In this class, we'll be studying difference between distance and displacement. Later on, we'll be studying speed and velocity. In this class, I'll be telling you various terms related to speed, like what is speed of a body, average speed, instantaneous speed, uniform speed, and non-uniform speed. Before beginning our new topic, let's first revise the previous classes. In the previous two classes, we have had few conclusions, in which the conclusion 1 was, when a body moves in a straight line without reversing its direction, then we can call that distance will always be equal to mod of displacement. That means, like in the example 1, where the body was moving from A to B and there was no change in the direction and the body was moving in a straight line, then the displacement was 6 meter and displacement also came plus 6 meter. So this conclusion is true, that when a body moves in a straight line without reversing its direction, then displacement is equal to distance. Okay, now let's move to our second conclusions. Our second conclusion says that a body moving in a straight line reverses its direction, then the distance will always be greater than the displacement. In this example, the body was first moving from A to B, then it had changed its direction and started moving from B to C. So there was change in the direction, but the body was moving in a straight line. So when a body moving in a straight line reverses its direction, then distance will always be greater than the displacement. Here also it was proved that distance came 15 meter and the displacement came minus 3 meter. So our distance was greater than the displacement. Now let's move to our third conclusion. Our third conclusion said that when the motion is not rectilinear, what is rectilinear motion? Rectilinear motion is the motion in a straight line is known as rectilinear motion. Here, first Divya was going from A to B, from her house to Priyanka's house. Then she moved to the school. So it is not in a straight line from A to B and then B to C. It is not a rectilinear path. So in this case, the distance will always be greater than displacement. In this example also, distance came 8 meter and our displacement came 402 kilometer. Okay, so distance came greater than the displacement. So distance is greater than the mod of displacement. In general, distance will always be greater than or equal to mod of the displacement. Okay, now if I bring this displacement in the denominator of this distance, then distance upon displacement will always be greater than or equal to 1. This is the another way of representation. Here I have placed the displacement in the numerator and distance in the denominator. Then it will be less than or equal to 1. Now, if somebody asks you what is the ratio of the distance to displacement, then you will say that it will always be either greater than or equal to 1. But if somebody asks you what is the ratio of the displacement to distance, then your answer should be either less than or equal to 1. Now, let's begin with the difference between distance and displacement. The distance is the actual length of the path covered by a moving body between its initial and final position is called the distance covered by the body. What is displacement? The displacement is the shortest distance between initial and final position of the moving body is called the displacement of the body and is directed from initial to final position. It will have the direction and that direction will be directed from initial to the final position. Okay. Now the distance direction is not associated with the distance. Why? Because it's a scalar quantity. Only the magnitude will be considered. No direction will be considered. Now in displacement, direction is associated with the displacement. Why? Because it is a vector quantity. In vector quantity, along with the magnitude of the quantity, that means along with the value of the quantity, the direction will always be associated with the displacement. Okay. Now here distance is a scalar quantity. Displacement is a vector quantity. Distance will always be positive. Okay. But the displacement can be positive or negative depending on the direction, okay, of the movement. Now in distance, it cannot have a value 0 for a moving body. That means it should never be equal to 0. It means that if the body will be moving, then it will be covering certain distance and that distance will always be non-zero. Okay. Now, in displacement, it can be 0 if initial and final position is the same. That means for the moving body also, it can be 0. Okay. But the condition should be that initial and final position is the same. See, for example, if I say that a body is moving from A to B, then from B to back to A. Okay. Now, the length of this AB is 2 kilometer. Now, the body has started moving from the initial position A. Okay. Now, the final position is also A because body is moving from A to B and then back from B to A. So, initial and final position is A. So, the displacement will always be 0 for this case. Okay. The another case is if a body moves in a circular manner. Okay. If it moves in a circle and if it starts from A and moves in this path and comes back to again A, then the initial and the final position will be A. That is same, right? Then the displacement covered by the body will always be equal to 0. If the body is moving, then how do we decide that how fast the body is moving? It will be decided by a quantity known as speed of a body. So what is speed of a body? Speed of a body is the distance traveled by the body per unit time. What does this mean? It means that speed of a body is how much distance the body has traveled in 1 second of time. It can also be described as speed is the ratio of the distance and time interval, or distance upon time interval or time taken by the body. Okay, now speed is denoted by v, small v. And remember, don't represent it with sharp small v. Okay, always represent it with curve v. Okay, it should be little bit curve. If an object travels a distance s in time t, then its speed v is v equal to s by t. Speed will be represented as small v, distance traveled by small s, and time interval by t. Here one thing is there, that don't get confused this s with speed. This small s will always be used to represent the distance traveled by the body. Okay, and small t for the time taken, and this small v for speed of the body. Now, what is the SI unit of speed? We know that SI unit of distance is meter and SI unit of time is second. So this is in meter and this should be in second. So meter per second. So SI unit of speed is meter per second. Okay, or meter second inverse. This is the another form of writing meter per second. And the CGS unit is centimeter per second or centimeter second inverse. Another unit of speed is kilometer per hour. Okay. Now, if kilometer per hour is given, then how can you change it to meter per second? If the speed is given in kilometer per hour, then how can we change it to meter per second? See, 1 kilometer per hour can be written as 1 kilometer upon 1 hour, isn't it? Now, 1 kilometer, we know it is equivalent to 1000 meter. 1 kilometer is equal to 1000 meter, and 1 hour is equal to 60 into 60 second. How? 1 hour is equal to 60 minutes, right? And we know that 1 minute is equal to 60 seconds, right? So therefore 1 hour will be equal to 60 into 60 seconds, right? So 1 hour is equal to 60 into 60 seconds. Okay, now this unit has become in meter per second. So solve this, will get 5 by 18 meter per second. Okay, now 1 kilometer per hour is equivalent to 5 by 18 meter per second. That means if the speed is given in kilometer per hour, in order to change it into meter per second, either do it manually like this, or you can directly do it by multiplying that quantity with 5 by 18. Okay, and 1 meter per second, this was 1 kilometer per hour. Now 1 meter per second is equivalent to 3.6 kilometer per hour. Okay. Now, what is average speed and what is instantaneous speed? These are two terms related to speed we need to study. Now, what is speed? Speed, we know that it is the distance traveled per unit time, isn't it? Now, why do we need average speed to study? This average speed need to be studied because, see, during the journey, if there is not a constant speed, let's take an example that we have to go from Alwar to Delhi. Okay. Now, during the entire journey, is it possible to maintain a fixed speed, a constant speed? A constant speed means a fixed speed. Let's take an example that you are moving with 40 kilometer per hour. Is it possible to maintain this 40 kilometer per hour in entire your journey? There can be a traffic also, right? So in the traffic, you need to adjust your speed, right? So wherever there is a situation to change the speed where the speed cannot be fixed to a certain value, then the speed will be variable, right? It will not be constant. So during the journey, if there is not a constant speed throughout, that is when the speed is variable, then we describe the rate of motion in terms of average speed. Okay. For example, that you have started from Alwar to Delhi with a speed of 40 kilometer per hour. Okay. Now, in the way you need to reduce your speed or you need to rise your speed, right? And you have changed your speed here also, here also, here also, and many more times, right? Before reaching to Delhi, right? So, if somebody asks you what was the overall speed, then the term which you will use for telling your speed would be the average speed of this entire journey. So average speed need to be studied, right? So average speed is, the average speed of a body is defined as the total distance traveled divided by the total time taken. Okay. So the formula of average speed is total distance traveled upon total time taken. Okay. Now, why do we need to study average speed? This is our reason. Okay. Now, what is instantaneous speed? Let's take an example that you have started at 11 a.m. Okay. And you have reached at 1 p.m. Right? Now, if somebody asks you what was your speed at 11:30, see, what was your speed at 11:30 means what was your speed at this instance of time, at this particular time, what was your speed of your car? Then we have to tell that our instantaneous speed. The instantaneous speed, the speed of an object at a certain instance of time, means the speed of the object at certain instance of time. For example, 11:30. So certain instance of time, the speed, we call it as instantaneous speed. So instantaneous speed is the speed of an object at a certain instance of time is called instantaneous speed. At a given instance time, what we read from the speedometer is instantaneous speed, isn't it? What is speedometer? Speedometer is that device in the car which tells us what is your present speed. That we call that device as speedometer. Okay. So speedometer gives us the instantaneous speed. Always remember this point. Okay.